this reaction is at equilibrium. What this is going to do is, it is going to pull an alpha proton from here. Yes or no? And this alpha proton will then make this enolate. So the carbanion will be here. What is it going to attack? It is going to attack another one of these molecules that does not have an electron pair there. So it'll attack one of the other aldehydes, has not reacted with sodium hydroxide yet. It is going to attack there. Where is the bond going to be? The bond is going to be between this carbon and that carbon from something else. So this is going to stay the same. Yes or no? That is going to stay the same. And the bond is going to be between here. So if I leave that like that, it will be between here and the other carbon-oxygen bond is going to look like this. Yes or no? This carbon is the alpha carbon, and this carbon is that carbon. What does this carbon have on it? It has an H, and it has CH2CH3. Yes or no? CH2CH3, and it has an H. That is the product. This is alpha, this is beta. This is a beta hydroxide. This can undergo a retroaldol. Now, what is a retroaldol? It goes back to the starting material. Because this reaction is reversible, yes? This reaction is an equilibrium reaction. So, forward is called aldol, and reverse is called retroaldol. Okay? Now, we can do something that is going to stop making this go back and forth, and that is elimination of this. So if we treat this with what can we eliminate that OH?
With heat.
Okay? With what?
Heat.
Okay, yeah, we can put water in there and make it a leaving group. But not just water, we can put acid, because there is elimination under acidic conditions and there is elimination under basic conditions as well, yes? Now, if you add H3O+, what is going to happen is this is going to get protonated, and then when you start heating it, this is going to leave, and you are going to form a double bond where? Here or here? Guys, where are you going to form a double bond?
And between the alpha and the beta.
Here?
No.
No.
No? Here?
No.
Why not? It's going to form a double bond between
The alpha and the beta.
these two. It is going to form a double bond between these two. Yes? Why did it form that double bond there? This double bond is alpha beta. And it formed the double bond here because of conjugation. Yes or no?
Yes.
And that is called the alpha beta unsaturated carbonyls. We did this last time, yes?
Yes.
Now, you can also have elimination if this is with sodium hydroxide, yes? So if you leave that sodium hydroxide, okay, and you just heat it, what is going to happen is elimination under acidic conditions. Now what's going to happen is the sodium hydroxide is going to do what? It's going to pull that hydrogen off, and it is going to form a double bond here, and what is going to be eliminated is OH minus. Yes or no? You guys are not used to seeing OH minus as a leaving group, right? But it's okay. We already have OH minus, yes? Yes or no? So you eliminate OH minus, you form water, and you form this, which is more stable than that. Okay? So in general, when you see alpha, beta unsaturated carbonyls, where did they come from? They came from an aldol followed by elimination. Okay? I want you to do here is, I want you to draw a mechanism in which you get the reactants from there. You get the ketones from there. This is called the retroaldol. So this is how it goes, yes? Under acidic, or this is under basic conditions? Basic conditions, yes? That's why that is not protonated, yes? So what is going to happen is this. That is going to make a double bond there, yes? Which bond is going to break? The bond between the alpha position and where the oxygen is. You see it? So this bond is going to break. So how is it going to break? This bond is going to 2 electrons to that carbon. So what this is going to give you is the boy so this aldol came from what reaction? The reaction of that ketone with itself. The aldol reaction, what is the product that you get? Aldol, just clean aldol, gives you beta hydroxy, yes? If it undergoes elimination, it's not called anymore aldol, it's now called aldol condensation. Aldol condensation gives you alpha beta unsaturated, yes? Still aldol. Okay, followed by an elimination. Yes? Provide the product. Why are you staring at me? It's your eyeballing me.
Waiting for the answer.
You just seem to be very close to the point.
My broad back doesn't let you see the board? I know.
What do you want to do with it for the last one? You want us to?
Tell me where it started from. So La Viste, what the deal is? You what?
Add water.
I won, you said?
No, add water.
Add water, oh yeah. Add water. Okay, so here is a ketone. Sodium hydroxide and Br2 would give you what? Sodium hydroxide and Br2 would give you Will give you bromination? Absolutely not.
I'll give you how.
That's a methyl ketone. It will give you a carboxylic acid from alpha halogenation 3 times, yes? But this is not that. This is sodium hydroxide. What is it going to do? It's going to pull a proton from here. It's going to make an enolate, yes? This carbanion in this is going to attack another one of these molecules here, yes or no?
Yes.
Hello?
Yeah.
There you go. I drew the same thing, yes? I drew the same thing. This carbon here is the one that is going to make a bond to what other carbon? To this carbon. A bond to that carbon. And this carbon is going to have an OH on it and whatever else it has, which is CH3 and you agree, yes or no? Are these difficult to draw? They're not difficult to draw? Okay, great. All right, good. Show me on the test. Of course, if we treat this with an acid or a base,
I drew the bond going down and then the rest.
that's
Does it
fine.
matter?
I draw it differently so you guys don't get used to drawing it one way. So you can draw it however you want. If it has the same connections,
Yeah.
you're fine. Okay? Some of you draw it going down, that's okay. How'd you draw it, Maria? Very good. If I treat this with, let's say, heat now, what do you get?
Alpha beta.
Alpha beta unsaturated carbonyl, yes? So I treat this with H plus or OH minus and heat. The important thing is here what? Heat is the important thing, yes? Because heat is going to favor elimination. So what is this going to give us? Redraw the same thing, yes? There you go. This where the OH used to be. I am going to draw the double bond here, right?
No.
Yes?
No.
Yes?
No. Where's the conjugation?
No?
No.
Why not?
Because it's
Not
not
alpha,
conjugated.
beta.
It has to be a here.
Okay. It has to be alpha beta unsaturated, yes? You don't make the double bond wherever you want.
Right.
You make the double bond in the alpha
Right.
and the beta position. You make the double bond here. Yes? Yes or no?
Yeah.
Where did this come from? What I want from here, every single time you see this, this is not a reaction arrow, yes? This is like, where did it come from? That's what that means. Retrosynthetically, what are the reactants for that? Tell me what are they?
So you have an alcohol.
You already wrote it?
Yeah.
No, I want the starting materials before the aldol. That's aldol condensation or just a regular aldol or retro aldol? No, the product is from where? Aldol condensation. Most of these have something called aldol condensation and crossed or mixed, which we're going to do next. So where did this come from? This came from reactants. This looks like an aldehyde to me, yes? Aldehyde. And that has alpha carbon. Does the reactant have these two carbons on it?
Yeah.
So that is one reactant. Yes or no? That's one reactant. That's one reactant. And the other one is that with an oxygen there, which happens to be the same, yes? So I am going to cut this here, and on this double bond, I'm going to have an oxygen on that side. The oxygen used to be where? If it's retro aldol, where's the oxygen at? I mean, not retro aldol. If it's just the aldol with the OH, with the hydroxy. Is it here or is it here? The OH is here, right? The dotted over. The OH is here. Of course, that will give you the same thing as this. How did you go from here to there? You treated this with what?
Sodium hydroxide.
Sodium hydroxide and heat. Okay, sodium hydroxide and heat will do it. Now, I don't like doing this, but I'm going to do it regardless. To confuse you. I want you to give me the Aldol product only for that reaction. What's the product? Okay, we are looking for alpha hydrogens, are we not? So sodium hydroxide will pull an alpha hydrogen from here, yes or no? Is this an alpha hydrogen? Yes, the alpha hydrogen will then, not the alpha hydrogen. This carboanion or this enolate will attack that one, yes or no? Hello? You guys became mute all of a sudden? Bond to this carbon here that has the OH. What else does it have? That? Yes or no? Okay? So, is there a possibility that after you make this carboanion here, does not meet one of these, and the carboanion meets another one of these like it has in the past? Yes? What would that product give you? That product will give you this, with the OH here, and another carbon. You agree?
Yeah, double bond.
No double bond, there's no heat, okay? Only aldol. My friends. Sodium hydroxide will do that, yes or no? This thing here is swimming in a flask, and the flask is filled with this and filled with that. When this is going to react, does it like this one more than that one? It does not care. It's a boy, yes, you see?
Females everywhere.
Two females, they both want it. So he's like, okay, give it to you if I find you, and if I find you first, then you get it. So it will react with this the same time that it will react with that. So if it reacts, this reacts with that, you get that.
And that one reacts with itself.
If this reacts with it, well, not with itself, because itself would be this, right? Now this is a boy. It was,
I don't know.
and it could react, I know what you said.
Professor, when you explain that, I totally get it. When you get all scientific, it's very confusing.
Yeah, I know, that's why I try not to get scientific. I invented the boy thing on purpose, okay? All for you guys. Sophia, this can react with this to form that, or this can react with that to form that. Okay? Because there's two of them around, there is a possibility that it can react
Can the
with.
second one form an anion?
Yes. That's what we're going to do next. And this was the, because I formed the anion here. Yes, let's say that now I form the anion here, on this side. Now give me the two possibilities of that reacting with the other two. And I wasn't planning on doing this, okay? But I did it anyway.
Also,
Yeah.
so, I'm reading off of what it says, a ketone such as an acetone is ideal because it removes an alpha hydrogen and yet does not go under cell condensation. Can you,
And what?
does not go under cell, like how we were talking about how it can be attacked by another one of itself, or it can be attacked by what you add on it. It's like you added a ketone instead of the aldehyde, and it only has to go with what you added as opposed to itself.
Because a ketone is less reactive, yes?
Okay, no, I'm asking.
I don't know what you're asking. What are you asking?
Why would you use a ketone as opposed to an aldehyde? Like, why doesn't the aldehyde, ketone attack itself?
Because these reactions are going back and forth, yes? And a ketone is less reactive.
Okay.
So when it does form it, it goes back.
Okay.
It does the retroaldo.
Okay.
I mean, not that it doesn't attack, it's that the equilibrium lies to the reactant side. So, what are the other two products? I have this, I'm going to write this intact the way it is, yes or no? I'm going to write this like this. And now the next bond, I'm going to draw them pointing down, yes? Next bond will be to a carbon that has the OH on it, yes or no? This carbon with the OH, which one do I put, that one or this one? Which one do you want first? You want this one first? This one first? Okay, if you have this one, the carbon with the OH will be here. What else does it have? CH2, CH3. Yes or no? If this reacted with that, it'll give you this. If this reacted with that, what would it give you? I am going to draw this one just the same. Yes? Carbon, oxygen. And now this one only has a methyl group and the hydrogen from before. How many different products is that? How many different products is that? That's 4 different products. Is that kind of stupid to do? A reaction in which you get 4 different products? It's kind of silly, yes? So in general, people do not do this, of mixing the base together with something that has alpha protons. So what you would do is, let's say you wanted this product. Yes? Where did that come from? Hello?
From the two. That came from the nuclear file. That one, all that.
Okay, by the way, this is called crossed aldol because you have 2 different ones, or sometimes called mixed aldol. So let's say we're going to do this, okay? You tell me what we're going to get as a product. Let's say we use this. In the first step, I'm going to add a base. And in the second step, I'm going to add this. What is the product? So in the first step, I am going to add a base. Which base would you like to use? Sodium hydroxide? That's all you have in your mind right now. Now, give me another base. Give me a base that will give you all enolate.
LDU.
Base of choice is most of the time LDA. Okay? You can use also sodium hydride, yes? They're both irreversible. Yes or no?
Yes.
Okay? You can use LDA, you can use sodium hydride or potassium hydride. Even calcium hydride. So, on the first step, what are you going to have? You're going to have formation of carboanion here, enolate, yes? And when you add this, since all of that is going to be the enolate, all of that is going to be the carboanion, then all of them are going to react with this. If I use sodium hydroxide and I pull off the protons from here, can this react with itself?
Yes.
Yes. This is why, instead of doing that with sodium hydroxide, you use a stronger base. That is going to pull every single one of these off, and then they're only going to attack that. Yes or no? When do we use LDA?
And you don't want to just react itself.
Use LDA a lot of the times, okay? So here it goes. Bonded to something else. That something else will have the oxygen on it. It has a hydrogen, and it also has CH2CH3. You agree? This does not react with itself because it's not sodium hydroxide. I put LDA in the first step. All of the LDA, pull the proton from here. All of it. Oh, by the way, that doesn't have the OH there, yes? It only has the OH if you add what after that? Is it water or H3O plus? You can add a little bit of acid. Okay? All this base is going to pull the proton from here, which will then react with all of that from there. You want another one, don't you? There you go. You like the chicken leg. Guys, the reason why I wrote all four of these there was for what? Was to show you that if you mix two things with alpha protons and you treat it with a base, what you get is a mess. Clear? So you should always treat one with a base and then add the other one later. So, in the first step, what do we get? Carboanion here, yes? Carboanion here? Yes or no? Carboanion here. So, I redrew that one just like that. Yes? So I don't get into trouble. And then, on this alpha, I am going to draw a bond to something that will have what on it? An OH. What else is that going to have on it? It's going to have a hydrogen, and it's going to have this with that and the chicken leg.
If we were to draw it the other way, how would it?
Huh?
If we were to draw it the other way, how would it work?
If you were to draw it the other way, this alpha carbon here is this alpha carbon. Yes, what does it have on it? CH3. This alpha carbon has that CH3. Alpha carbon has a CH3. It is also bonded to this one, which is that one. And what does this have on it? It has the rest of it, CH2, with a chicken leg here, and it has a hydrogen. That's how it looks. If you do not include the hydrogen, then it looks like that.
So it doesn't really matter where,
Guys, it's not about whether it's confusing or not. You gotta try to spend time. Instead of going, oh, it's too confusing, I'm not looking at it, you have to try to understand. Because it's not always going to be pretty for you. If I give you the drawing on the test, what do you do? Oh, it's too confusing, let me see. But I'm gonna sit you here in the front.
so it doesn't matter where, you know, you put like the ending part, as long as you put a carbon on the alpha proton, it doesn't matter if you continue it there or do it at the other end of a carbon chain, doesn't matter, you just have to put at least one carbon there.
No, not at least one carbon, it depends on what you start
Well,
with.
you have to put it in the alpha proton.
Yeah, and the alpha proton, yes. Okay, if I now treat this, if I heat this now, what do you get? Alpha beta unsaturated, yes, dope on here. If I treat this with heat, just maybe base or maybe acid, what do you get? Double bond there. Okay? Yes or no? Tell me where this came from. What's happening? What? So where did those come from?
Looks like a bicycle. You finished? You good?
Okay, guys, what's the strategy here? No, let's do one first. So you don't mess all of them up, yes? Hopefully you learn here, you can use your knowledge for the other one. So, where did this come from? Which one, where do I break this?
By the alpha, beta.
I'll break it, the alpha carbon to this carbonyl, which is this one, and this one, yes?
No.
Break it between this one and this one?
No, you break it right at the alpha.
I break it between the alpha carbon of the carbonyl and the one that has the OH on it. So I will break this bond here. And I break that bond. Don't look down. Why are you looking down? Why are you looking down? Don't look down. Look down. No, I don't want you to write it down. I want you to pay attention so you don't miss this stuff.
Professor, why did you break it in the middle of the alpha bond?
What?
Why did you break it in the middle of the bond versus actually at the alpha?
Because what I broke was the bond. So, look here. Carbonyl, yes or no? What does it have there? CH2, CH3. You agree?
Yes.
Carbonyl, what does it have here? After I broke it. CH2, CH3. There you go, that looks like that. The other one is going to look like this. That's plus. This carbon here, what does it have on it?
An OH.
An OH. That came from a carbonyl, yes?
Yeah.
So, carbonyl. What am I going to put on this carbonyl? It has what else? It has a hydrogen. So, that was an aldehyde. And what else does it have? Carbonyl,
And it has
CH2, CH2, CH3. CH2. Is that it? CH2, CH2, CH3?
Yeah.
This 1, 2, 3. Which one did I add to this? Which one was the enolate from here?
No,
Which
actually,
one?
I like
Which one did I treat with a base?
the
Aldehyde.
The ketone.
How do you
The
know?
second one.
How do you know I treated that one with a base? I treated this with a base, yes?
Yes.
How do you know I treated this with a base?
Carbonyl.
Because this carbonyl is intact over there. It's intact. The one that has the OH is the one that got attacked. So that's LDA. In the second step, what do I add? In the second step, I added that. And in the third step, H2O. Fine. Is that good? If I heat this bad boy up, what are you going to get?
Double bond.
Very good. Alpha beta unsaturated. Try to use it for one of those only. Only do one at a time, yes? And then we will go through it. So if you don't learn the first time, maybe you learn by the fourth time.
Professor, you said to break it between the carbonyl and which one?
I never said to break it between the carbonyl. I said break it between the alpha carbon and the carbon with the hydroxy. So you gotta break it alpha beta. Just do the one on the top, don't do any of the other ones. If you already did them, it's okay.
Which one do you want us to do? Which one do you want us to do?
The top one. Okay, ready?
Almost ready, almost.
No, that can't take that long, man. You're not gonna have time to finish the test. It's hard?
It is very hard.
It's little drawings, man. It's kid stuff. So, here's a carbonyl, yes? That will remain the same, yes or no? So, carbonyl, what does it have on that side? That? Why is this like this here? Does that have any alpha protons? This one? No, it does not have any alpha protons. So if you are not going to use a symmetrical ketone Doesn't matter if you take the proton from here or from here. It doesn't matter because this is symmetrical. If it's not symmetrical, you might get two different products, yes? So what is done most of the time is, it only has either symmetrical or one with alpha protons or an aldehyde, yes? This does not have alpha protons. Yes or no? Now, which bond did I break? This one?
No.
No.
The one
The other,
Not the one on
between the alpha and the beta. So in the middle of the bond.
this one.
No.
I feel like I'm Dorothy.
Oh, you feel like Dora the Explorer?
It's like, no.
That's
In between the first and the second
Okay,
carbon.
I am going to break it between
The first and the
the
second.
alpha carbon to the carbonyl, here's alpha, and the carbon that has the OH, which is here. I go to squiggly line, is that squiggly?
We just talked about that.
Which left side?
It's the T, you can't, it's
Here?
just the alcohol.
Here?
No nitrogen.
Has to have the carbon with the OH. You have to break it in between the carbon with the OH and the alpha carbon. You can't break it here anywhere because it doesn't have the OH. So I broke it there, that's one of them. That's one of them, yes or no? What's the other one? I am going to draw a carbonyl here, and that's going to have hydrogens and hydrogens on both sides.
Yep.
Well, look here. This carbon here has how many hydrogens?
Two.
It has one hydrogen and another hydrogen, so it has two hydrogens here.
Nice.
How's that? Which one did I treat with a base first?
On the left.
Did I treat this one with a base?
No.
No alpha protons, yes? So I treated this with a base and then I added that. Okay, trying to do that one. I'm getting tired of this Aldol. I'm ready for Clayson. Maybe I should just do one last one. One last one? Okay, guys, what now here? What bond do I break?
Between the OH and. Right in the middle.
Between this one and this one, right?
No.
Between this one and alpha to this carbonyl.
Yes.
How many times I'm going to say that?
Exactly.
Here is the carbonyl. Here's the alpha carbon. Yes, alpha. And then to the one that has, I'm going to break it there. If I break it there, I am going to get
With a metal.
this. Yes or no?
With a metal.
Methyl. Where the methyl group? Where is the methyl group at? Explain this to me. Let me cover this for you. Do you see any methyl group here?
No.
I don't see it. It's just that. On this side, I'm going to make a double bond to that oxygen. Yes or no? So, I'm going to make a double bond to that oxygen. What does this have?
H.
A hydrogen. And that business has this thing here with a cyclohexane and a methyl group there.
Oh, I finally got it right. At least the back side got it right.
That's good, man. That is how we slowly do things.
Okay.
It's better to do slowly, yes?
Yeah.
Slowly but surely.
How about this one? Gouch, you got it? Wow. Dora, you got it?
My bad.
Dora the Explorer, Dora.
Well, I think we're a guy from Diego, right?
No, you can be Dora, man.
I don't know yet, I'm still figuring out myself how to do it.
Okay, yeah. Okay, guys. What the deal is? I am going to cut it where? Here?
No, the alpha, no.
I'm going to cut it. Here's alpha to the carbonyl. Here is the carbon with the oxygen. I'm going to cut it in between those two, yes? If I cut it there, that is going to be once again what?
It's gonna be just that.
What do you mean, just that? This is called
No metal.
cyclohexanone.
No metal group. Okay. You have your heat,
And then,
the metal group.
what am I going to have? What did you say? A metal?
You're gonna have
Metal?
it has
Like this metal?
We're gonna have one carbon.
Except metal, right?
Metal, yeah.
Well, you can never have a DVT on that leg, right?
That's a good question, I'm not even sure.
Probably not. You don't know what a DVT is? Me neither, I just heard it somewhere.
Bonds inside.
Okay, so here's the carbon, yes?
Right.
It's gonna be double bonded to an oxygen.
Right.
You agree?
Yes.
What else does it have? CH3
And
that business.
cyclohex.
You agree?
Yes. Yes.
Yes.
Okay.
One less two.
I don't know about you guys, but I'm ready to retire.
I tried H attached to the carbon
It took a while.
What happened?
I tried H attached to the carbon, is that okay?
An H here?
No, another H.
Because of the five bonds.
Oh, that's fine.
Like that?
Just like that.
Yeah.
He's a biologist.
You got carbon having one.
A carbon needs to have how many bonds, my friends?
Five. For him, five.
Okay, yeah, for him, but-
Oh, is it 4?
Maybe that's the phosphate one. That's the
If-
phosphate.
What?
Phosphate one.
Yes.
Yeah.
Okay, guys, what's this one?
That one has heat.
Okay, hurry up, we don't have all day. You're stretching or you just woke up? Okay, so what do we do here? It's a problem, yes? No OH. But the double bond came from an OH. Where was the OH at? It was on the beta carbon. Here's alpha. Yes or no? Alpha to the carbonyl. Here's beta. The OH was on this here, on the beta, because it's beta hydroxy. So I'm still going to cut it between the alpha and the beta. Okay? So let's say that that came from this. I don't know if this is going to help you or not. That came from this. Yes or no? That came from that, yes?
Yes.
Okay, and this came from? This came from carbonyl now here. I broke this bond. on one side.
H.
What do I put on that side?
H.
H.
Cállate la boca y no te hacer tus cosas.
I'm telling you, girls are amazing. So, do this one here, and that will be the last before we start something else.
On the last one, you do the same process, but the last step you had,
Yes.
Everything's understood. I'll just do that.
Okay, so what's this here, guys? This is situation, yes? Mike the situation.
Well, you have your
Here's a base, yes? It's gonna put an alpha proton from somewhere.
right on there, right there.
It could pull it from here, yes? And if it pulls it from here, it's gonna attack something else. If it pulls it from here, it could attack this one here. If it pulls it from here, it can't attack that because that will be too small of a ring. Yes? So we're gonna pull it from here. This is called intramolecular. Intramolecular what? Intramolecular aldol. Intra. Who wrote intro?
I don't know.
It's very clear, it's an A there, my friends. No, thank you. Intramolecular aldol. You can pull a proton from here, you can pull a proton from there, yes? Now, what size rings are the preferred size rings?
5.
5 is the fastest, 6 is the most stable. So, 5 and 6 is what you get. I never taught you the difference between them and how you can get one above the other, so you don't worry about it. So, it is going to get a proton pulled off from here or from here. Where do you want it pulled off better? From here? It doesn't matter? It matters for the picture we're going to draw.
Really?
Of course.
It doesn't matter.
It doesn't? Okay, which one did you draw then?
I put
I'm going to give you the more stable one.
Okay, let's say we pull it from here, yes? If we pull it from here, this is going to attack that one there. So if we pull it from here, this ring will have 1, 2, 3, 4, 5 carbons in. Yes or no? How many? This ring is going to have how many?
5.
5 carbons. There it is. Is that carbonyl going to stay intact, yes or no? Yeah. Is the carbonyl with the electron pair, yes? That's going to stay intact. Which carbonyl is that going to be? Let's draw it here. Yes? This is the carbon that attacked. It could be this one too. Which one do you want? Doesn't matter? Nothing matters to you, yes? As long as I do it on the board, it doesn't matter, right? When you have to do it, it does matter. So, look, let's say I want to leave this the same here, yes? Let's say that's the one that attacked there. So this turned around, and there is going to be an OH where?
Right there.
Here? The OH going to be there.
No.
The OH is not going to be in alpha position. The OH is going to be on the beta position. It's going to be 1, 2, The OH is gonna be here. Yes? What else? Anything else?
Methyl.
Okay. It attacked it here, so the OH is gonna have that business, and it's gonna have a methyl group. So there is gonna be a methyl group there. Yes or no? You gotta count after you do this, you gotta count the number of carbons. Maybe I made a mistake. 1, 2, 3, 4, 5, 6 carbons in total, yes? 1, 2, 3, 4, 5, 6 carbons in total. This is a 1, 2, 3. This is alpha, this is a beta hydroxycarbonyl, yes? But we treated it with what?
Heat.
With heat. What that means is, the heat is going to make this. Here's a carbonyl, where's the double bond going to be at?
Third carbon.
Double bond is going to be alpha beta. Guys, do you like the intramolecular aldol? Huh?
Yeah.
Well, you better like it, because we're gonna have intramolecular everybody. This is called Claisen. So aldol is aldehydes and ketones. These are esters. Okay? So, different name, yes? If I treat this with a base, what base should I use? Should I use sodium hydroxide? You look at that structure. La viste, my friends. Should I use sodium hydroxide? No. Stop texting your girlfriend, man. Why not?
If not, you get a
Do I add water? Yeah, you do get a carboxylic acid. How do you know? Because you already did it somewhere? Huh? No? You've never done it? I'm just trying to see if you ask me for a letter of recommendation what I should say on the letter. Yes, you cannot use sodium hydroxide. And the reason you can't use sodium hydroxide is because sodium hydroxide will attack here, and that will lead, and what you are going to form is a carboxylic acid. So most of the time, the base that you are going to use for this will be a base like an alkoxide. Most of the time, you will use the same base that is on this side. If this would have been OCH3, then the base you use is OCH3 minus. It is still a base. And the reason why you use this base is, if this attacks that, and this eliminates, forming another ester, it would be the same ester of this is. Okay? So, if you do that, what you are going to get is, once again, you give me the product. Give me the product. Same as before, yes? Give me the product you expect from before. So, this is a ethoxide, yes? And what this is going to do is, it is going to pull a proton off from here. And then this is going to attack what? It's going to attack another one of these without having the proton taken off, yes? And this is what you are going to get is, yes or no? Bond to the one that has this stuff. Let's say it's under basic conditions, yes? So let's say stays negative, yes?
Oh, no orange?
No. My friends, basic conditions, no OH yet. Okay? And what else does that have on it? It has this, and it has a CH3. Yes or no? How does that look? Is that what you get?
Outstanding. Yeah, no, 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 watch it.
But it's unstable.
Guys, does that make sense, or is that crazy?
I'm gonna leave it like that.
That looks crazy.
It's unstable.
I'm not gonna leave it like that.
Okay,
I'm saying,
okay.
is that what you get, yes or no? Oh, the metal means a metal. No, but she said metal before. It was methyl, yes? Oh, okay. You gotta stick your tongue out. That's right, spit. That's right. Yes, this methyl
You are terrible.
comes from carbonyl, yes? That's our methyl. The electron pair from here attacked another one of these. Okay? Yes, the boy attacked that. Yes or no? Guys, I'm gonna smack you guys. Say yes or no.
Yes.
Yes. And now what this does is, that acts like a leaving group. Okay? And what you are going to get from there is, yes, carbonyl and CH3. So what does that give you? Instead of giving you an OH, because there is a leaving group on that ester, when you form this O with a minus, the leaving group leaves and you reform this carbonyl. So in the Claisen, what you form is a dicarbonyl. So instead of the OH, what you have is a carbonyl. Why is the carbonyl there? Because the OET was the leaving group. Okay? Yes or no? You want the mechanism for this? Do you like the mechanisms? I mean, it's not like the mechanism is... Do we have time?
No.
What time is it?
It's 11:18.
Plenty of time. Plenty of time to do 5 of these mechanisms. Look here, Luis. Huh? Who's Luis? Oh, my. Luis is my friend from college. Okay? There is a base. Why is this base, and not some other base?
Because of the T on it.
Okay, very good. So this base is going to act like the base, and it's going to pull my friend off here. Yes or no? It pulls it off, and what it's going to do is carb 1 ion here, which is not the best resonance structure in the world. Yes, resonance structure will be the one that it is, so I'm going to draw the resonance structure here, okay? That's a resonance structure, yes or no? This is a resonance structure. But most of the time I don't show you a resonance structure from here. I show you this resonance structure, which is not the best, so I can do the attack. Now this is going to attack what? This is going to attack another one of those. There it is. Attack there. Electron pairs to the top. what that is going to give you is that carbon, oxygen. Yes or no? Attack was here, now a bond between the alpha carbon and this. What does that have on it? An OET and CH3. Yes or no? What is going to happen next is this. There's a minus charge here. The electron pair goes here, the leaving group, ethoxy. Ethoxide, I should say. Yes or no? Now what do I have? I have that base, the pKa of ethanol is more or less what? Like 16, yes? No, not 25. pKa of an alcohol. 15, 16, whatever. 16. What's the pKa of a diketone? Around 9. So what that means is that this base is going to do what now? This base is going to pull one of these protons off. And this base is going to pull that off, and that's going to go there. And what you are going to form, what did you say? Yeah. I didn't want to keep going, but then I have to, because I got to show you. Yes? Resonance structure to this. You agree, yes or no? So because we are under strong acidic, under strong basic conditions, you're always going to have that anion there. Okay? So in order for us to quench that, we need a proton source. Okay? Proton source, like water or acid. Okay? We want to treat it better with a mild acid, yes? So because of that, we're going to treat this with H3O+, and that is going to give us the product. So this Claisen thing, so if you go back to the Claisen, in the first step, you're going to add this, which, is this going to have anything next to it? This is going to look like sodium ethoxide or potassium. And in the second step, because you're going to have this negatively charged species here, what's this here? Is this supposed to be an arrow?
Yeah.
In the second step, you're going to add this H3O+.
I don't understand what the point is of taking off the proton and putting it back onto the acid.
No. There is no point to it. Why do you think everything has to have a point? When a dog bites you, he has a point? What's his point?
He doesn't like you.
A dog just bit you? Well, you appear to be biteable.
But why does it do that?
It does it because of pKa. Sophia, explain this. The pKa of the alcohol is 16, and the pKa of that is 9. So if this is there, there's no point to it. This is just going to take it. That's it.
Okay. And then we just have to put it back on?
So you just have to put it back on, yes. And you do it with an acid.
Thank you.
Okay? So, what I care about is that you know this. Guys, look here. This is what I care about. You first add this base, and then you add an acid. The reason why you add an acid is because of this here. Okay? Maybe if you had something else, you wouldn't need to add an acid. Let's do another problem. You want another one?
Professor, don't erase the board.
Erase this
What
side.
do you mean, man? Look.
No, what do you mean? There's so many errors and little points.
Okay, let's not do it like that. Let's do it like this. So, tell me what the product is. Oh, we got 4 minutes, don't we? Let's do another one then. Yeah. We didn't try. Yeah, remind me next time. Okay, guys, the first one, what is it? It's gonna attack this one here, yes or no? I'm gonna write it the other way. OET on this side, and this is alpha carbon, yes? It's gonna attack this one here, yes? There will be a carbonyl here because that OR left. Oh, I put an OR. Put ET. So, yes or no?
Now, would it be wrong if there was like, I put the ring on the left and would that be wrong? That's the ring.
I don't know, let me see.
Like, I pretty much put the ring here. Can't do that.
It doesn't have an OET.
Yeah, no, it was.
Next, what's next? Couch, what the deal is? Carboxylic acid. So, LDA is going to do what? Pull a proton from here, yes or no? LDA is going to pull a proton from there. So, I'm going to redraw this. ET. This is with another ester. Ester with another ester. This is called Claisen. It gives you another carbonyl because that left with those groups on it. H3O plus, yes. Because you generate the methoxide or the ethoxide, whatever it is anyway. Yes or no, guys? Is that good? You want a quiz? No. We still have 2 minutes left.